Okay, so I've been making YouTube videos for a while now on Java tutorials, and one of the problems I've had is getting the microphone set to the best level. I downloaded some VU meter software from the net, and the problem with this software is it would crash after a short while. So really what I need is a visualization of what's coming out of the microphone, whether it's hitting the peak of its limit and whether it's set loud enough. So for fun, I'm going to write this in Java. So let's get started. So I start by cutting and pasting code from the Java tutorials from the Oracle website on capturing audio. I'm trying to get it so when I speak into the microphone I can see data, and I'm outputting that data to the console. So I'm reading the data line here and plotting the values that I'm reading to the console. So I'm just going into a loop. At the start I'm starting up the thread which will stop things. That will call the finish method after record time, and I'm also starting the main thread which is going to loop through the data line, read the data, output it to the console. Now when I run I can see values coming out. If I remain quiet, the values seem to be 0, 1 and -1. If I talk, the values change, so they don't seem to change very much though, so I'm going to plot these into some sort of a chart. I'm going to add a user interface and plot these values with a line, so that, and I'll have this line scrolling across and we'll see what it looks like. I'm not sure if it's going to work, but I'll have a go, so I'll do that now. Okay, so I've got a sound graph that extends the panel, and this has an add byte method, and it's going to store this byte in a byte array. But if the number of bytes in this byte array exceeds the width of the panel, it's going to remove the first one. So this byte array is going to have the number of bytes in it for the width of the panel. And then in the paint method we're working out where the center of the panel is, the center Y position, and then we're going to plot the bytes by drawing lines between them. So I think I've got it here that the tick size is 1/256th of the height, so the center position should be 0, 127 and -128 would be the extremes. So let's put this panel in a window. The height and width should resize because it's inside the method, so it doesn't matter if it draws too wide. So let's just see if this is going to work. So this JFrame is going to contain the sound graph, and it's also going to have the add byte method that will just pass the byte onto the sound graph. And then I'll just construct that frame in our main method and see how it looks. And then when we finish the main method, I'll change the way this works later, but when we finish we just dispose of the frame. So now all I need to do is pass the byte, instead of system out print lining, just pass it to the frame, and then let's see if this works. And I think I forgot in the sound graph I need to do a oh no, I am doing a repaint. Okay, so let's see if this works. Right, I've got the frame, it's very small at the minute. Okay, I'm not seeing anything, so I'll just debug. I'm getting a line, which is promising. Oh, yes, that is working quite well, but it's not, it's remembering the old line. But testing. Yeah, okay, so a bit of debugging. Okay, so I'm setting a foreground colour and a background colour, and I'm going to paint a rectangle in the background colour from 0, 0 to the width and height of the panel, and then I'm going to set the colour to foreground colour before I start drawing my lines, so we can customize the colours later, but I think this will look a lot better. So let's take a look at this. I need the window. Okay, so that looks okay. Testing 1 2 3. Okay. Okay, so I've just put the paint method in a synchronized method and also synchronized add byte, because we're getting index out of bounds and null pointer exceptions, and I think that's because one thread is adding the bytes and the other thread is painting, so that should have got rid of that. Testing 1 2, so now I can't see any exceptions, so that's better. I think what I'm going to do is I'm going to have this as the sort of immediate graph. I'm going to make another graph in another panel in the frame, which will be a slower updating graph, so that I can see, if you know what Audacity looks like, you can kind of see the sound wave going all the way across. I want a kind of more long-term sound wave, so I can see that I'm filling the whole range without peaking off too much. So let's add another panel. I'll adjust this panel so it can be either. Okay, so let's have a go at that. So here I've now got an array of sound graphs. I'm only going to have 2, I think, but maybe we might have more later. And in the add byte method, I'm going to loop through them all and call add byte for each of them. I'm also going to set the size and position of this panel here now. Okay, have I done everything? Let's see. Now we should have the immediate graph and a less frequently updating graph. Doesn't work. Sound graph 1. No pointer exception. Oh, I just need to initialize this. So I think now it will work. Testing 1 2 1 2. Okay, so looking at these charts, I think they're quite good, but they're not quite doing what I wanted, because it seems that the this chart here is only giving us just a fraction of the total amount of sound that we could have. I think it seems to be about a quarter. So I think I think it's because decibels is reported as sort of exponential. So I think a quarter of the plot on here is louder than a quarter of the volume. I think if I multiplied this volume by 4, we'd be peaking out all over the place and it would sound terrible. Now we can see there that when I said peak, I seem to be able to hit the top of the chart with the letter P. Right. So I think I'm going to make another type of meter. This sort of old-fashioned type that hits the peak and then comes down as it goes, and maybe even a needle. No, maybe. Yeah, I'll try some experiments. I'll try and get another type of chart to look at. Okay, because I'm adding a second type of graph, I've turned sound graph into an abstract class which extends the panel, and then in the sound frame I'm going to have a list of these sound graphs which are the abstract classes, and then we can just create whichever type we want. So I've renamed the old sound graph to wave graph, and I'm now going to add a peak meter. The abstract method add byte is going to be present in all of these graphs. So in the sound frame we're just going to loop through the sound graphs and add the byte to that graph. And what the peak meter I want to do is I want to fill a rectangle across the screen. The width of it will be the absolute value of the byte, and then I'll subtract from that value, I guess in a thread, or I'll see how this is going to. Actually, the add byte method gets called predictably, so I will I'll subtract 1 in the add byte method from the previous value. If the new byte is higher, I'll add up. If not, I'll subtract 1, so the peak meter will sort of hit the peak and then come down and peak back up if the sound is louder. So let's do that. Okay, so I'm here. When I call the add byte method, if value, which is the value of the peak meter, is greater than 0, I subtract 1 from it. If the absolute value of the byte coming in is greater than value, I set the value to that. And then I'm going to fill a background rectangle to clear off the panel, and then the tick width is the width of the panel divided by 128, which should be our maximum peak value because that's half a byte. Then we set color to the foreground color, work out the width, which is that tick width multiplied by value, and fill the rectangle with that width. So now I'm just going to add this peak meter. I'll set the main panel to be 2x2 grid layout, and I'll add a new peak meter chart and see how that looks. Testing 1 2, so that works. It's way too quick at disappearing though, so Testing 1 2, and I think I need to do, yeah, it needs a bit of work. So I'm going back to the wave graph now and converting this to use our new decibels instead of the bytes. dBs. Other than that, it will work in exactly the same way as it did before. The only thing is I've had to work out the peak value because the value from 0 to 128 isn't the same. So in sound frame, I work out the peak value so that I can divide it down. Okay, so with all our graphs converted to a logarithmic scale, let's just fix an error here. Let's see what this looks like. Okay, so now I've converted all my charts to use a logarithmic scale. I think that's looking pretty good. I think I'd like to color coordinate things a little bit, and I also want some fourth chart here, or maybe I'll turn this bottom chart into, I'll fill the screen with it. I'll put it border layout south so it fills the whole south panel, and I'll color code that with a green, yellow and red. So the yellow can start somewhere up here and the red can be the peaking. And I think this upper right chart, I'd like to speed that up a bit, or yeah, I'd like to speed the movement up a bit. We don't need to see that far into history, so I'll make these changes and then we'll see how it looks. Okay, so I think I've completed this now. So what I've got is the green zone of sound is sort of 50% volume on the logarithmic scale. So really we want frequently to be going over that level, I think, and going into the yellow zone, which is from 50% to 90%, and the red zone's at the top. So I think the sound volume is correct if we're frequently going into the yellow but not going too much into the red. And I think we can see that we're not peaking the sound, although when I said the letter P seems to be very sensitive to peaking, but I think it probably sounds okay. So that's my VU meter. I'll go through and show you the source code in more detail. Okay, so let's have a look at what we've got. We've got the main VU meter class, which sets up the audio. So in the start method, it gets the microphone audio and it starts to monitor it, and it just loops through in a while true method and calls add byte to the frame object. Now, our frame object we'll look at in a minute. It's this sound frame here. Now, the buffer that we're reading from the audio input stream, we read 2 bytes, one for left and one for right. And although that's still set as add byte, it's actually adding 2 bytes, a left and a right. And that's the first 2 values from this buffer byte array here. Then when we close the window, we're going to system exit and call finish, where we'll shut down the line and dispose of the frame. This is just the audio format object that we're using, and we're also running a stopper so that after a specified amount of time, I've got 200,000 milliseconds there. Yeah, after a specified amount of time, we're gonna get this thread to call finish and just stop everything. I haven't really finished what this is doing, but the idea is the program is going to run for some time and shut down if the user doesn't shut it down before that. Now, the sound frame, this is a graphics class. First, I'm going to have a look at what a sound graph is. So a sound graph is an abstract class with an add decibels method, where we tell it's a J panel, but this add decibel method, we're just going to tell this panel that this is the current decibel output. I'm not sure if I'm using decibels properly, but decibels is a logarithmic scale of the value that is coming out of the bytes. So sound frames. So this is the main frame. We work out the peak value on the log scale. So the peak for the byte would be 128, because the byte comes out either plus 127 down to minus 128. So the largest value we're going to see is 128. And then we have left sound graphs and right sound graphs. The left sound graphs, we add two wave graphs, one initialized with the value 1 and one initialized with the value 50, and a peak meter. And we have the same for the right graphs, and we lay them out. So we have a wave panel which is in grid layout 2x2, and we have the left and right, the left and the right on the left and the right, and we have the two wave graphs at the top, and then at the bottom we have the two peak meters. We'll have a look at what they are in a minute. And when we call add byte from the VU meter, we're just going to get the left graphs and the right graphs, get the decibels for these byte values, and loop through the left graphs and set the decibels or add decibels to the left graphs, and loop through the right graphs and add decibels for the right graphs. Now, what a wave graph does, when we add decibels, we have a double array here. dB stands for decibels, so I'm thinking now of decibel values. I have a list of those. If this list exceeds the width of the graph, we're going to remove the first one, and we're going to add the one we add in this method to the end and repaint the graph. Now, the parameter we passed in was the frequency that this graph is going to update. If we set the frequency to 1, the graph will update every time we call add decibels. If we set it to higher than 1, it will skip updating if that step isn't hit. So if we say 10, we'll update it every 10th step. But if we are not updating, if the value that we pass in is higher than the current value on the end, we'll replace the value on the end with this value. So in other words, we won't miss the peaks if they happen. And if we make any changes, we'll call repaint. Repaint calls a synchronized method. I think that should still be synchronized. A synchronized paint method. And that is drawing to an image. It's drawing the waveform, really. It's also drawing zones. So it's drawing red zones at the upper and lower 10% ranges, yellow zones in the 50% range, and a green zone in the middle. And then here it's working out the X value is just the index through the array in the decibel values array, and the Y value will be the proportional value up and down, and it's just drawing a line for each plot in our decibel values. The peak meter, that has a value, and the value gets pushed up by the decibel value, and then it will gradually reduce by 0.001 each step. But if the decibel value exceeds the current value, it'll push it back up again. So the idea is the bar will shrink down, but it will peak up. So I'm calling this the peak meter. In the paint method, we're drawing it's just a bit more complicated than just drawing one rectangle, because we're drawing red, green and blue boxes. So if we watch it all in action, so at the top we have the left and the right immediate values, so we can see the shape of the immediate sound wave there, and beneath this we have the left and the right 50 stepping update wave graphs, and at the bottom we've got the peak meters. So we can see if I make a nice pure tone, we should see a sort of sine wave appearing at the top here. So yeah, something like that. And if we start hitting the peak, so if I say P very loudly, because the word peak seems to make it peak, P, 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 then we can see on these graphs that we're hitting the top and getting flat bits across the top, and that's not what we want. So really, to get my microphone adjusted right, I think it's adjusted right now. We're going into the yellow zone with pretty much everything we say, and we're not going into the red zone. If we do go into the red zone, it's only momentary, and we can't see any straight lines where we're hitting the peak value. As I resize it, it will update it. So I think I should really add some borders around the panels. But apart from that, I think the effect is reasonably good, and I think I can load this up every time I want to see if I've got my microphone levels right. So that was the idea. So that's it for now. So thanks for watching.